Nice to see you. Hello, hello. Cool. Okay, so yeah, welcome to Privacy in Moonbeam. I'm going to get my slides set up. Hello. How does that look? Or maybe I can make this a little bit more.
That's perfect.
That's good? Cool, cool. Hi. Welcome everyone who's arriving. Yeah, this was a long time coming, this event. We're very excited to kick it off. So I think I'll start on the intro. So yeah, welcome to Privacy on Moonbeam. It's an event hosted by the ZKValidator. ZKValidator is actually I'll tell you a little bit about it, but what we do is we aim to support privacy and ZK technology over multiple blockchain networks. We are currently live on 10 networks, 3 of them in the Polkadot ecosystem, including very obviously Moonbeam. We're also on Polkadot and Kusama. So we're a Moonbeam collator. We're also validators on other networks, including a number in the Cosmos ecosystem, like Cosmos, Osmosis, Evmos, and Agoric. We're on Near, Mina, and Celo as well. And we're currently always evaluating new networks and looking to expand into different places. Maybe to share a little bit about what we do with these networks is what we're usually doing is we're aiming to support privacy or zero knowledge research. Sometimes the networks already have it built in. Sometimes we want to bring it to them. And so obviously what we're doing is we're running validators, but we're quite strategic about who we validate with. We act as advocates for privacy on these networks. We participate in governance. We support emerging teams. And we also launch initiatives to promote and fund ZK Tech initiatives, a little bit like this one. And here's our amazing team that's grown quite a lot this year. I mean, yeah, I think we've doubled this year or something. So that's pretty nice. We're 8 people now, and we are always looking for, great people who might be able who are aligned with our vision and want to join us. So yeah, keep an eye out for jobs and stuff as we post them. So I want to share a little bit about general ZKV initiatives. So we have run in the past event series focused on ZK Tech and privacy. This is in a way one of the first ones that we're doing as a real hands-on workshop, and we're doing, we had a vision for really trying to see this tech that didn't exist kind of come to light through this particular series. ZKV also was an initiator of the ZK Hack project. So ZK Hack we just wrapped up our ZK Hack 3 event. So ZK Hack is a learning hub. There's events, there's content, and it's very focused on onboarding new developers into ZK Tech education, like being able to actually code specifically with zero knowledge proof stuff, introducing them to libraries. I do want to just highlight there's a whiteboard sessions video. If you go to zkhack.dev, you can actually find the ZK whiteboard sessions. We released that last summer, and it's a great kind of learning resource. The first 3 are from Dan Bonnet. It's great to onboard you just into the concepts of ZK Tech and what that is. Yeah, we also do things like the Open Legal Report working group. So this is a group of a lot of the ZK projects, members of their teams coming together and trying to find out if there's risks or opportunities that we could actually build initiatives around. So maybe more working groups, preparing reports, trying to work a little bit more with legislators. And it's very open. And if you're interested in that, do get in touch with us because we are always looking for new participants. ZKV also does early stage funding. So we do we do a little bit of investment into early stage projects. Usually either they're ZK focused or we think that we could bring ZK to them, similar to our network strategy. We also were involved in ZK grants. So we did the Gitcoin ZK Tech side round. We were one of the co-organizers with 0x Park, trying to get funding into the hands of really early stage contributors. We've also supported the Z Prize initiative, which is looking at accelerating hardware, ZK hardware. And they just finished, actually, they announced kind of their winners just recently. And at our ZK Hack event yesterday, we actually had a small presentation from Z Prize. It'll be on the YouTube channel too. I think someone just shared that. So yeah, YouTube channel is a great place to find out about a lot of these things. And then the other thing we do, and we don't do a lot of it, but we're looking to do more, and that's building ZK enabling tech. So tell us a little bit about this event, Agnieszka.
I don't see the slide change yet. Oh, no. So the goals for this event, first of all, we want to introduce ourselves to the wider Moonbeam and Manta community, but we also want to hear from you. We want to get to know you better. We want to get to know your needs and interests around the ZK topics. Main goal of this event is obviously to explore the topics of Polkadot's cross-consensus messaging protocol, XCM. What is really exciting, and Anna already said a little bit about it, is that through this event series, both teams actually made an extra effort to make this tool usable for us, which you're going to see through the walkthrough, a use case for privacy on Moonbeam as a demo. Hopefully, as well, will spark ideas for the future ZK application using XCM, and we're going to get you excited to use this tool. Okay, so what's on the agenda for today? After this introduction, we're going to jump right into the 2-hour workshop, Transact Remotely through XCM, where both teams will be presenting. So both Moonbeam and Manta will be presenting. First, we're going to start with the Moonbeam presentation, then we're going to jump to Manta. And as far as I know, Alberto will finish the third part. After that, obviously, we're going to wrap up a little bit, tell you about exciting things that are coming. And here I would like to say a huge thank you to the Moonbeam Treasury that supported our idea of creating this series and provided us with a grant that made it possible. We are also one of the first companies that went through this grant process, which we are very, very proud of. And I want to say a thank you to our media partners. So ZK Podcast, you were asking about the video. Yeah, it's Anna's initiative. So you were asking about the video. It's going to be recorded. This session is going to be recorded and it's going to be uploaded to the YouTube channel of the ZK Podcast. And things to look out for, like I mentioned, privacy in Moonbeam is a series. We already did our Twitter Spaces. I don't know if you've seen them. If you haven't, 2 weeks ago we had the Twitter Spaces. You can find it on our Twitter. Today we're gonna have the first online workshop, hands-on, which I cannot wait to see, to be honest. And we are also planning around April 2023 a workshop that is going to be in person. So look out for that. If you want to be up to date with everything that is happening, all our events regarding the Polkadot ecosystem and the ecosystem itself, sign up to our newsletter. Yeah, I think Hector already posted it in the chat. So please sign up to the newsletter not to miss any information that we have for you. And yeah, thank you very much for everybody that signed up and is with us today. If you want to contact us, please use the email events@ZKValidator.com. If you want to learn a little bit more about us, please go to our website, ZKValidator.com. Follow us on Twitter, ZKValidator. And now it's the time that we were all really, really hoping for, and we're excited to see. I want to introduce on the stage Alberto from Moonbeam and Georgi from Manta. Guys, I hope you are with us. It always
takes a moment sometimes.
So yeah, for the presenters to come on stage. So I hope everything is okay, and we're gonna see.
There you go.
We already see it, but
and maybe just.
I forgot that I had to go and click on the up right corner as like share audio and video. I completely forgot about that. So even though we rehearse it, we always rehearse and then we forget about doing this stuff.
Yeah.
Hi, Georgi.
Hi. Actually, just a note to the audience, you should not touch the blue button because when you click that, you're asking to be brought onto the stage. So don't click the blue button. And just know that there's 2 chats for this. There's an events chat and a sessions chat. And so you're going to be trying to keep this in the sessions chat. I hope I come in okay. Is my internet very bad?
Yes, your internet is perfect.
It's okay?
Yes.
Yeah, and also
Okay,
I wanted
perfect.
to add that in the chat you will see chat and Q&A, and make sure that you ask your questions in the Q&A section so that we can read them out loud and answer all the questions that you guys have. So, all right,
Okay.
should I get started then?
Yep.
All right,
And if
cool.
you sharing,
Yep, I'll share my screen. And so, yeah, like Agnieszka and Anna said, I'll be doing a lot of talking first, so bear with me. And then I'll do a demo as well. And then Georgi will take over. He'll do his part on Manta. And then I'll do a last demo in which we sort of combine everything. But I'll start working on my part of things. So, all right.
perfect.
You see my screen?
Yes, we see your screen.
Awesome.
Everything is okay. Good luck.
Yeah, thanks. All right, cool. So yeah, my name is Alberto. I work at developer relations at Moonbeam, and today I'm going to be presenting. It's going to be sort of like a mixed presentation between, things about Polkadot, things about Moonbeam, things that are generic about XCM, and then Georgi will take over and explain similar things, but on the Manta side. But my part will be a little bit longer, I think, because I'll be talking more general things about Polkadot and XCM as well. So I do developer relations on Moonbeam. I think unluckily, I've been working with XCM for over a year, I think. And I say unluckily because it's a really, really complicated topic. Agnieszka said something that I found really interesting. It's like, this is going to be like a hands-on workshop, and it's going to be super, super, it's not something that is straightforward, right? And so the idea is that when you guys are using this knowledge to build the applications on top of, your responsibility will be to make sure that it's easier for end users to use the tech that we'll be showing today. And so today for the agenda, let me click on the Q&A just in case. So today for the agenda, I'm going to briefly go over Polkadot. It's going to be super short just to set the stage. Then going to talk about an overview of Moonbeam. Then we're going to start going into an XCM overview, and I'm going to briefly show a tool that might be helpful in this sort of scenarios. Then we're going to talk about remote Transact, and this is going to be mixed up with the part of XCM overview as well. And last but not least, we're going to do the first demo of the two demos that I prepared today. The first one is going to be mostly focused on a simple XCM interaction with Moonbeam and Manta, but it's not going to be like the main juice of things, because we're going to wait for Georgi to present the Manta side of things to then come back and do a little bit of a more complex demo. So Polkadot in 1 minute. And so the idea of this slide is that you're not going to be a Polkadot expert, but it's sort of like set the stage so you understand why Moonbeam exists, why Manta exists, and the whole idea behind the Polkadot architecture. And so the main sort of idea of Polkadot is a specialization and connectivity. There is no one blockchain to rule them all, right? There is no one blockchain that can do everything, but there are many best blockchains. And so the idea is that Polkadot acts sort of like a hub, or it's normally called a relay chain or layer 0, that it's able to connect all these specialized blockchains and secure them. So the idea is that these specialized blockchains don't really have to worry about the game theory and the complicated parts about consensus, about making sure who's telling the truth. But basically, they only have to worry about making sure that their blockchain does something really well, and that they can just produce a block. They don't have to make sure that this block is okay or not. These elements or specialized blockchains are called parachains. And if you didn't know, the parachains terms comes from parallel blockchains. And so, like I said before, they provide a specific functionality to the ecosystem. Maybe as a parachain by themselves, this blockchain doesn't do anything fruitful, for themselves. But as if you think about it as an ecosystem, it can provide a very, very cool service to the ecosystem. And actually, I think this workshop is a really good example of this, because Moonbeam by itself is just a smart contract parachain, but it doesn't have any privacy built into it, right? You can think of it as like Ethereum. Ethereum doesn't have any privacy tools that are basically embedded into the blockchain itself. For that, we can use Manta as a privacy layer for Moonbeam, right? And how can we do this? Like, why does the Polkadot allows all these sort of participants of the ecosystem to work with each other? And the main reason is XCM. So XCM, as it says on the slide, is the way that these participants can communicate with each other. And the keyword here is that they can do so natively, right? So when you can say that, you know, Ethereum can talk with Avalanche or with Moonbeam, you're talking that you have sort of like a middleware called a relayer or a bridge or a GMP protocol in which you're sort of trusting this infrastructure provider. But in the case of Polkadot, you're already trusting the consensus mechanism. So you can more or less say that, you know, XCM is embedded into that. So it's a little bit safer. So I probably went over a minute, but hopefully this gives you an idea of what Polkadot is. And the main proposal of Polkadot, that is, you know, you have each of these parachains does something very, very, very well, very optimized, but together they can provide a stronger and more optimized product for blockchain users. So with that, you know what, it's Moonbeam. And Moonbeam, it's, I think I mentioned it before, it's a smart contract parachain on Polkadot that it's focused on Ethereum compatibility. So we want to be sort of the most Ethereum compatible and frictionless environment to build smart contracts on top of Polkadot. And in order to do that, you know, as with any other EVM compatible chain, you need to have sort of like an EVM as a base layer, right? And so you can see here at the bottom that, you know, the EVM is sort of the core layer of all the EVM compatible chains, but we provide sort of added layers of value on top that makes us different from any other like EVM chain out there. The first one is that we're built with Substrate, which means that it's Substrate is the SDK to build blockchains on top of Polkadot, and it makes us basically connect to Polkadot quite easily and benefit from the native interoperability, right? And we can do other things like, you know, benefit from Substrate's modularity to create some sort of modules that allows us to expand certain things, like, for example, the staking module that the Pure Stake team, which is built in Moonbeam, developed. Another key feature is the Web3 RPC, which makes any Ethereum compatible tool like MetaMask, Remix, Hardhat, and all these tools work out of the box on Moonbeam. So basically, this means that every tool on Ethereum that uses the Ethereum JSON RPC can more or less work directly on Moonbeam without any major modification. The other one that it's a big one is unified accounts. And this means that Substrate natively uses an account system that is very different than Ethereum's, right? You will see in today's demos that, for example, Manta, they use a different sort of account naming system, if we want to call it like that, at a very high level. And so this really creates a lot of friction when you want to interact with like Ethereum tools and the Ethereum API, because it's not really like compatible. So we've modified the Substrate account system to use Ethereum as style accounts. And so that's why on Moonbeam you can stake using your Ledger or MetaMask and so on. And you always talk about, you know, Ethereum style accounts. And last but not least, Moonbeam offers basically a frictionless Ethereum dev-like environment with expanded features. So all the tools that you expect are available on Moonbeam, like, you know, Chainlink, the Graph, Etherscan, that's called Moonscan, Gnosis, Safe, multi-friendly fork, and all these tools that, you know, Ethereum developers sort of expect from an Ethereum compatible blockchain as Moonbeam. All right, so I mentioned before that Moonbeam offers sort of like an EVM with expanded features. And what does this mean, right? If Alice wants to interact with the Moonbeam EVM, she's going to interact through the Ethereum interface using the regular wallets that you know. And so basically, but what happens is that if Alice wants to interact with the more powerful part of Moonbeam, which is a Substrate interface, she actually cannot use sort of the regular wallets, as you can see here on the image. But the Substrate interface is really powerful because it's what gives end users access to features like staking, governance, and XCM, which is a key feature in this demo that we have prepared for you today. And so the way that you can do this on Moonbeam is basically through a special things called precompiles, in which they have a Solidity interface, so you can interact with them as if they were smart contracts. But this allows Alice, for example, to access staking or governance or XCM features through the Ethereum interface. This, like I said before, this allows, you know, Alice to sign a transaction on MetaMask and then do more complex things like, for example, send an XCM message. And so, yeah, let's talk a little bit about XCM, which is, I think, the main topic of today's sort of demos and collaboration with the Manta guys. So this part is going to be generic. So it's not going to be Moonbeam focused, even though, you know, you might see some Moonbeam logos around. But the idea here is sort of to provide a general knowledge on XCM and how it works. So XCM is like the native intra-communication layer of Polkadot. So XCM by itself is just like a message with a given format, right? At a high level, the way that I like to explain it is like an email, right? An email, we all know that you have like a given format that it's like, it's embedded into what, when you, in your mind, when you write an email, you have the introduction, you have the main body, you have the part where you say goodbye. So XCM is similar to that, but that is a message with a set of given instructions, and a combination of these instructions, it's what results in a specific action, right? Let's say you have 20 instructions to select from, like extending up from the chair, turning right, walk 10 steps, and then flick the switch, right? If I do these 4 instructions in that specific order, the action or the result will be that the lights will turn off. But if I do like, walk 10 steps to the right, and stand up, and it's something completely different is going to happen, right? The other important element is the XCM VM, which is basically the virtual machine that interprets sort of these instructions and executes them. So in this case, it would be like my brain, right? That hears the instructions, understands them, and then just starts, doing an action. And these XCM messages basically move around through communication channels, right? And they're unidirectional. There's no like, if you set up a channel with another chain, it's not a two-way road. It's a one-way road only. And this is what allows message to move in that given direction, right? And these channels have names. And if you send a message from a Moonbeam to the Polkadot relay chain, it's called an upward message passing, so UMP. The other way around is downward, so the DMP. And then between parachains is called XCMP, but the current implementation is called HRMP, which is basically, it actually is routed through the relay chain and so on. So let's give a practical example so you understand, how XCM works. And we'll start high level, and then we'll dive down into the instructions involved in each part of the steps. So let's say Alice on Polkadot, she wants to transfer some dots to another account called Aleph on Moonbeam. So Alice and Aleph could be, separate people. They don't have to be the same. But the way that this works is that what happens is there's one instruction that is going to get executed on Polkadot, and then 4 instructions, more or less, that are going to get executed on Moonbeam. And I say more or less because there might be some slight variations in these instructions, but the end result might be exactly the same. And so what's going to happen is that Alice, through an XCM instruction, she's going to transfer some dots to a special account called a sovereign account. And it has to be through a special XCM instruction, because if she does a regular balance transfer, it's just going to be a really, really nice donation to the sovereign account. The sovereign account is a special type of account that it's keyless, so like nobody knows a private key. And it's controlled by an entire chain itself, right? You can think of it as like an account that can be controlled only through the democracy, for example, right? So, or only through a specific interactions that are considered secured. And so basically this Moonbeam sovereign account is in charge on Polkadot to hold these dots. And then there's another XCM message with that instruction. There's an XCM message that is sent to Moonbeam that when it gets executed, the end result is that you're going to mint a representation of the dots. In this case, we call it XC dot. And these are going to be sent to Aleph, which is the target account that Alice decided to transfer the tokens to. So remember, 4 instructions on Moonbeam, 1 instruction on Polkadot, and the sovereign account is a special account that it's holding these dots in the meantime, so that when you send it back, you're going to actually transfer them out of the sovereign account to the destination account that you want. So let's go into a little bit more detail, as I said before. When you Alice transfers the dots to the Moonbeam sovereign account, it's using this instruction, this XCM instruction, and you can find in this URL sort of the more like details on when it gets executed on the code. But basically, this instruction, what it does is it's going to take funds from Alice account, and it's going to deposit them to the Moonbeam sovereign account in this particular example. This instruction also is going to send an XCM message to the destination, and that to the destination blockchain, and that message is going to start with 2 more instructions for security reasons, and I'll explain why there's a security concern here in just a minute. So remember that basically this instruction is the one that does the asset transfer on the origin chain, but also sends an XCM message to the destination chain, which is the same as the sovereign account owner, basically. So basically, the transfer reserve asset instruction code snippet, it's shown here on the slide. It looks really complicated, but I want you to focus on this part. You can see that this line of code right here, the one on the top, is the one that actually transfers the assets to a destination account. And the second part here at the bottom is where the actual XCM message is built. And then it gets sent, as you can see here at the bottom line, to a destination blockchain, which is here in the destination. And you can see that that message starts with the reserve asset deposit and clear origin instructions. So in the case of Moonbeam, when the message it's received by Moonbeam, and this is an async operation, right? So the message gets executed on Polkadot, and basically just Polkadot hopes for the best on Moonbeam. There's no way to say, hey, only execute this. This is going to be successful on Moonbeam. You just execute it on Polkadot and just send it and just hope for the best that it's going to get executed correctly on Moonbeam. So the first instruction is called reserve asset deposited. And this is the instruction that is going to mint the XC dots, but it's not going to transfer it to Aleph just yet. It's going to actually put the tokens in a special state called holding. And the analogy that I like to give here is that it's like you're putting the money on the table. Like you have it there on the table in front of you. It is there for people to use it. And the only account that can mint these assets is the sovereign account of Polkadot on Moonbeam, all right? And that is basically the origin of the XCM message when it's received by Moonbeam. The message, if I send a message from Moonbeam to Manta, the origin or the account that it's going to dispatch is going to be used to dispatch the XCM. The first thing that's going to happen is that it's going to be the Moonbeam sovereign account, right? If this is the message that gets received. And so after we mint the XC dots, the next instruction has to be clear origin so that this dispatcher account can no longer be used to dispatch stuff. All right. So that's why it says removes origin register information. So you cannot use this account no longer because it could be dangerous and it could create a security concern. And I think there was a problem like this on Kusama in the early ages of XCM. The next instruction is by execution. And this is basically you're just saying, hey, I want to do some work on Moonbeam, right? So I need to pay for it. And you're going to actually pay for it with the money that it's on the table, the money that it's on holding. So let's say the person that it's going to, do this work has to, say, hey, I'm going to take this part and then, reserve it so that I can pay for block space on Moonbeam. And the last instruction is the one that finally, we're going to grab all these tokens that are on the table and then give it to Aleph, which if you actually follow this example along, if she sent 1 dot from Polkadot, she's not going to receive 1 dot on Moonbeam because she had to pay for execution. So it's going to be a little bit less. So let's follow a similar example with the remote Transact. I think by now, token transfers are a little bit boring. And so I think this is where the actual juice of XCM it's going to be because it's where, we're going to be able to talk with Manta and do some privacy stuff on Manta, like the example that we have for you today. And so the remote Transact example is basically, let's say once again, Alice, she wants to do some special operation on Moonbeam, right? She could be doing a simple balance transfer on Moonbeam or a staking operation on Moonbeam, or even, calling a smart contract on Moonbeam. So the way that this works, once again, is through a special combination of XCM instructions. She's going to send an XCM message with something called Transact and some bytes, okay? And these bytes might not mean anything on Moonbeam, on Polkadot or on Manta. But on Moonbeam, it's an instruction saying, hey, go to this module, go to this function, and call this function with these parameters, all right? To Polkadot, once again, these bytes don't mean anything. Polkadot probably cannot understand what the bytes are for. But when the message is received on Moonbeam and it gets executed on Moonbeam, these bytes actually mean something, and it means what the person wanted to do from Polkadot, basically. The way that this works currently is that Alice on Polkadot actually owns an account on Moonbeam, but she doesn't know the private key of this account on Moonbeam. She only can control this account by using a specific combination of XCM instructions. The cool thing about this is that you can do a lot of like remote transacts or like remote stuff on another chain without not even having to own an account on that chain or having a private key on that chain, right? You can do stuff like, for example, yesterday I was doing a demo when Alice on Polkadot, she did some Glimmer staking on Moonbeam without even having to sign a MetaMask transaction. And so that this account, it's calculated through a special like mechanism that I'll explain a little bit later, but we call it the multi-location derivative account. And this is actually going to be used in the demos that we have for you today. The instructions related to the remote transact and the origin chain, you might have some instructions for, fee payment or whatever, but this is not really mandatory. And on the destination chain, in this case, Moonbeam, you might have the send origin, which is this instruction is what actually creates the multi-location derivative account. And it has to be included in some scenario. So we don't actually accept a message that doesn't have the send origin instruction. Well, actually, it just depends on the case. Then you have the withdraw asset instruction, which is going to remove assets from an account and put them once again into holding, into this special state that it's putting money on the table. Note that this instruction is different than the one from the transfer example, because in this case, the assets are already in the account that we're like withdrawing them from, right? And this account is related to the descent origin. So in this case, if we go back here, it's like, taking Glimmer out of the multi-location derivative account from Alice and putting them on the table to use them for something else. The next instruction is to just pay for execution time on Moonbeam. And the last instruction, which is the most important one, is the transact instruction, which is you provide some bytes that are going to be basically, understood in this case by Moonbeam, and it's going to result in an action happening actually on Moonbeam, like I said before, a balance transfer, a staking, or something else. All right. I don't think there's any other question. There is no question, so I'll just continue. And so just to give a more high-level example of what can you do with this sort of like transact stuff, and we're going to show one today with like Manta, but one really cool one that is right now in production, it's liquid staking with Lido, right? So a user basically signs a transaction on Moonbeam, using MetaMask, Ledger, Trezor, whatever wallet they normally use. And this transaction is going to basically interact with some Lido smart contracts, and they're going to mint like ST Dot, which is the staked version of Dot that exists on Moonbeam. But more interestingly, what's going to happen is that the Lido contracts are going to use the XCM precompile. So it's a precompile to sort of like send XCM messages with a transact instruction on another chain to another chain, in which basically we're saying, hey, Polkadot, I want to stake these tokens to these validators, right? And so basically, if you think about what this means, a user on Moonbeam, signing with MetaMask, it's staking tokens on Polkadot, that it's an entirely different blockchain with an entirely different account system. And it's just basically just signing a transaction, and that's it. The system is a lot more complex than what I'm showing here on the image, but it's just to give you a high level idea of how this works. And this is pretty incredible, right? Because two not completely separated blockchains, because they have this sort of like relation that it's the relay chain on Moonbeam, but they're talking with each other natively, and basically you can stake on another blockchain without having to have a private key on there. So this is pretty cool. All right, so let's go through another example of remote transact, but this is another really cool one, which is entering the Moonbeam EVM through XCM. And so the idea here is that you're still going to use the same transact instruction, But instead of saying, hey, I want to target the staking module, you're going to target a special module called the Ethereum XCM palette, in which allows you to enter the EVM through an XCM message. You're going to actually do this from a multi-location derivative account, which I already explained briefly. Or you can actually also do it through a proxy execution, but this is a little bit out of the scope of this presentation, so I won't actually define this here. As always, if you have any questions or any comments, you can always find links throughout the presentation to our doc site, which has a lot of details on these sort of topics and so on. But let's talk about what is a regular path for the happy path for a regular or a remote EVM call through XCM. So if you want to call the Moonbeam EVM, what's going to happen is that you as a user are going to sign your transaction using the typical wallets that I've mentioned before. And basically, you're submitting a sign transaction using ECDSA cryptography for signing. Let's say it like that. And so what happens is that the Frontier RPC extension, which is a module that we use on Moonbeam, is going to basically communicate with the Pallet Ethereum to validate a transaction and then send the validated transaction through the Pallet EVM, which is another module, to the Rust EVM, right? So there's a lot of middle steps between the user and the Rust EVM, which is going to execute the call. And you're going to see some logs in the block explorer and so on. However, when you are doing this through XCM, the story it's a lot different, because a user is signing a message, an XCM message, using a completely different, it could be using a completely different cryptography, right? In this case, a typical one on Polkadot is SR255.9. And so basically, this is going to send an XCM message to Moonbeam. But when Moonbeam receives this XCM message, there is no track of the signature. Basically, we can just receive a message saying, hey, this message was sent by Alice in Manta, let's say, right? But what we do basically is that we calculate the multi-location derivative account with that specific thing called, Alice in Manta. And then we execute this through a special palette called the palette ETH Ethereum XCM, and then basically send the validated transaction to the Rust EVM. Because this message doesn't have any signatures, the validation is done a little bit different than through the regular Ethereum palette Ethereum validation, because in the left-hand side, you do have a signature. So there's one key difference there. And so the main differences between remote EVM calls and regular EVM calls can be sort of summarized in three things. First, if you're more familiar with the Ethereum sort of tech, you know that the EVM transaction hash is actually calculated with the signed Ethereum transaction, right? So if there's no signature, you can actually have two remote EVM calls have the same transaction hash. To prevent this, we actually use a global nonce instead of a nonce per account. So there's, if Alice sends the first ever remote EVM call, she'll have nonce 0. Then if Georgi sends the second one, he'll have nonce 1, and so on. Because there's no signature, you cannot use easy recover, right? So, you cannot, recover the sender from the signature. However, in Ethereum smart contracts application, the message.sender still exists, and it's the same one that it's on regular EVM calls. And it's actually also included on the Ethereum transaction receipt and so on. And another really weird thing is that the gas price for these remote EVM calls is 0. And this is because we're charging this call on an XCM level and not at an EVM level, right? So when you get to the EVM, you already pay for your execution. So the EVM is not going to charge you anything. So on the right-hand side, I provided an example of what if you actually get the transaction by hash of a remote EVM call. And this is actually what you get. You basically get, a transaction that has no signature. As you can see here, the VRS values are basically nothing meaningful. You have a gas price of 0, right? And you have also a nonce that is not actually represented of the account, your account's nonce, but the global nonce from the palette itself. And so this is not basically representative of how many remote EVM calls has this account done. So why I am presenting this is that even though it's a little bit out of scope, but I'm presenting this because, you might find some use cases that you are in Manta and you want to sort of tap into the Moonbeam CVM to do something cool, right? So I think this is something that you can do as of today in our testnet in Moonbase Alpha. And so that's why I wanted to present it, just in case it's helpful for the hackathon. Hopefully it is. Before we start, there's a lot of content to cover. So before we start going into more details, I think one thing that we have to talk about is multi-locations, because that is something that is very unique about the Polkadot ecosystem. And in the demos, we're going to be showing them. At least I'm going to be showing them. I'm not sure if Georgi is going to be showing them, but we'll be using this. And if you're going to do an application between Moonbeam and Manta, at some point you're going to use multi-locations. I can bet money on this. So think about what Polkadot is, right? Polkadot, it's an ecosystem of accounts on different blockchains, of tokens on different blockchains, of multiple blockchains out there, right? And so multi-locations is a way to sort of represent all these things with one well-defined structure or well-defined way. The way that I like to see them is basically as folder paths, right? So you can think of as Polkadot as a root folder or the parent folder of everything. And then you have each parachain as a subfolder inside of this main folder. And then you have all these accounts, tokens, and everything in there just lying in those folders, all right? And basically, if you think about, the terminal line, if you're in a folder and want to get to another one, you use a specific command, right? And so basically, the way that multi-locations are used is that you can represent anything, like I said before, chains, tokens, accounts, and they're expressed in relative terms to an origin. So if I'm in Manta, I am going to target Moonbeam using a specific multi-location. But if I'm in Polkadot, I'm going to target Manta using a separate multi-location. And they have two main things, a parent and an interior. The parent can be seen as how many hops to an upper level or an upper folder you're doing, all right? And the interior is basically the content in that level. And you can use actually no fields to define it. You can use one field, two fields, three fields, etc. Right? So let's do some examples so you get more familiar. Let's say we're in Polkadot, and if you want to, you're in Polkadot and you want to target Polkadot, you actually would say that your multi-location, it's parents 0, interior here, right? If you want to target Bob, which is an account on Polkadot, you just have to say, hey, I am already in Polkadot, so parents is 0, and the interior is like, I'm already in Polkadot. I just need one field, which you have like predefined fields, and one of them is account ID 32, which is basically Polkadot Bob's address. If you want to target, let's say, I have the Akala logo, but let's say Manta, from Polkadot, you have to say, hey, I am not going one level up. I'm actually going one level down. So I just keep parents at 0. And then the interior would be just the parachain ID of Manta, which in this case, in our testnet, it's 2084. If I want to target Alice, which is an account on Manta, I'm not doing any level hops to an upper level, so I'll keep this parents at 0. But I need now 2 fields to define Alice on Manta, which it would be Manta's parachain ID and then the account ID of Manta itself, or of the account in Manta itself. So please keep these things in mind, because in the demo we're going to see this stuff, and hopefully this is helpful to understand it. If we go to Moonbeam, it's very, very similar, right? So the parachain will be using the parachain ID, and the account would be, the main difference here is that because we use a different account scheme, it would be using account ID 20, which is the Ethereum style accounts, because these are 20 bytes, and Manta Polkadot uses 32 bytes accounts. If I have, let's say, a token, let's call it Albert token on Moonbeam, you can actually let Polkadot know that this token exists by just saying, hey, the parents is 0, but then I need 3 fields. In the case of Moonbeam, we use 3 fields to define tokens. One of them is, the first one is the parachain ID, then the palette instance, which is like the module that is hosting this token. And then the general index of the asset, which it could be 0, 1, 2, 3, whatever the asset ID is when I registered it. So if we are in Moonbeam and we want to target, other things, it's very similar. So inside Moonbeam, the main difference now is that we don't need to specify the parachain ID, because, we are already in that folder. if we want to target Bob or Polkadot, it is the same as before, but we only need to put parents 1 because we're going 1 level up, right? If we want to target Akala or Manta, we just have to put the same as before, but in this case, only parents 1 because we have to go up 1 folder and then down to the parachain ID. And then Alice, it's more or less the same as before, but we just have to put parents 1 because we have to go, once again, up 1 folder, Manta or Akala, and then the account ID itself. So hopefully this gives you sort of like a better understanding of what multi-locations are and how you can use them for when building an XCM message. All right, and I think this is the last part that I have before the first demo. So this is a little bit of a tool that is part of a repo that it may be helpful to sort of understand what's happening when you're doing an interaction. And I'm actually going to use it on the demo. I'm actually not going to use it, just show you the result because it's a lot easier. And so basically, this is a way that you can use to decode XCM messages, right? So when you send an XCM message from Moonbeam to Manta, what Manta receives is a bunch of bytes. And so humans, I mean, normally cannot read bytes, right? I mean, bytes are not something that it's really easy to read. And so basically, this tool allows you to transform these bytes into the instructions, which are human readable. And so you can start sort of understanding what's happening and help you debug certain things, right? So you can actually decode XCM messages that go between 2 parachains. In this case, for example, we have one between Moonbeam that Moonbeam received from Akala. We can decode messages that are, from a parachain to the relay chain. In this case, this is the middle example here, a message that received Kusama and it was sent from Moon River. And we can decode messages that are from the relay chain to another parachain, which is downward message passing messages, right? And then you have here a bunch of inputs that you can provide. If you want to read more about it, you can click here on the URLs where you have, examples on how to use it and so on. And then you can also have examples here if you clone the repo and run it yourself. So why, like I said before, why do we need to decode XCM messages, right? And this is a practical example of why. If you go, this is Moonbeam, right, on Polkadot JS apps. And if you go to a blog that Moonbeam received a XCM message and you find it on the blog, you will see that these are just bytes, right? And when you have problems with XCM, this is not really helpful because you got to understand what's going on. And so, this is, like I said, it's not helpful, right? So if you actually go back and run this, let's say we got a message from Akala and the message was, in block 1649282, you will actually run this exact code snippet here. And basically this will print out all the instructions. And then you will be able to understand at least what's happening. And if there was an issue, to debug it. So it's actually a pretty useful tool for you to, sort of play around with XCM. All right, I think we got through the main part of the presentation. So let's do the demo. Let's do our first XCM demo. And so you will be able to see, first of all, I want to extend a huge thank you to the Manta team because when we actually met like a couple months ago, a lot of this stuff were like, not working. And so, there was a huge engineering effort on making sure that they onboarded a parachain into our testnet ecosystem. We did a lot of tests, a lot of back and forth, a lot of meetings, and this is just to show you a little bit of the result of all this. So what we're going to do is that we're going to do a balance transfer. It's a normal balance transfer, nothing fancy, all right? But we're going to do it via XCM. We're just going to complicate things because we like to complicate things. And so we're going to do a balance transfer, but instead of going to in this case, Calamari or the Manta deployment on our testnet, we're going to do it from Moonbase Alpha, all right? So this is the things that we sort of like need and what's going to be helpful to sort of like look into it. We need first an account on Moonbase Alpha, funded with our token, dev, so we can send in transactions. We need to calculate the multi-location derivative account. And this is done really, really easily with a script that it's linked here in the URL. It is not really like, it's not straightforward, but it's not super, super hard. And then when you calculate it, you need to fund it with Calamari tokens, Calamari testnet tokens, right? So don't think that these are real Calamari tokens. In this case, for this example, I'm actually this is the multi-location derivative account that I calculated. So if you want to follow this along, you need to calculate this yourself and then ask us to send you some tokens so you can try it out. Remember when I said that when we're doing remote transacts, you need to have some bytes that are not really understood by Moonbeam, but are actually, pretty clear instructions on Calamari. So this is step number 3. We need to go to Calamari and build sort of the encoded call, right? Or the bytes that are going to actually, when they're going to be executed, they're going to do the balance transfer. And then we also need to go to Moonbeam and then build our own XCM message and then basically just get the call data there so that we can just replicate this. I left some, important URLs and some tools that we're going to use to sort of look at all this stuff that is happening. And then in here, you have also the XCM Tools repo to decode the XCM message, all right? All right, let's get to it. Let me see. Cool. So the first thing that we're going to do, and I'm going to show you this so you can get a sort of like a sneak peek before we actually do it, is that we're going to head to Calamari on Moonbase. You can see here, and we're going to build sort of the transaction. It's like we're going to do a little bit of cheating and build it, but then we're just going to copy this down here. And what this is basically the encoded call data, or like I said before, the bytes that represent on Calamari a balance transfer to this particular account and of this value right here of 1 KMA token, all right? Then you can actually get this encoded call data as well using the Polkadot.js API. So I have left sort of like a code snippet here that this is how you would do it. You have to instantiate the provider, provide the destination, the amount, create the API provider, and then do the API transaction balance transfer with the destination and amount, and then just get the encoded call data using this here. So this is very, very similar than here, just in a nice TypeScript, JavaScript, code. The next thing, and this image might be a little bit too small, but that's fine, is that we're going to go to Moonbase Alpha and we're going to build our XCM message. But instead of building it sort of manually, right? I mean, it's like, you're not going to grab, I want to do this instruction. I want to do this instruction. You're going to use actually a palette. And a palette, it's like a module that it's going to help you build an XCM message without you having, to build the XCM message, piece by piece. So you're going to use this transact through sign method, and you need to provide this information. And I'm going to go through this in the demo. Basically, when you build this out, this is the bytes that represent this on Moonbase Alpha in case you want to check it out later. And I think that's it. So this is the way that you would actually get that encoded call data using a JavaScript, TypeScript script. But it's similar as before. You just need to instantiate sort of the provider and then put some stuff down like the destination. This is a multi-location. As you can see here, we have a parents and an interior. We have a fee, and I'm going to explain this a little bit, later on when I actually do the demo. All right. So I think I have it here. So let me go out and all right. So we have, and I'm going to zoom in, don't worry. All right. Because I know that it might be hard to see. Hopefully this huge zoom that I put, it's enough for you to see this. Cool. All right, so what I have here, this is Calamari, right? This is Calamari on Moonbase Alpha. It's a testnet. And I have my account. It has 2 KMA tokens. Hopefully you can see this well. Let me hop in the chat just in case. Cool. Yeah, and Frank, there's a link to the slides. I'll provide it at the end of the presentation. So actually you're not, distracted by the slides because I know they're great. I'm just kidding. But but I'll provide it when I finish the presentation so you can take a look at it after. So we have this account on with 2 KMA, and this is going to be the destination account for our balance transfer. I also have here the multi-location derivative account. I have plenty of funds here, but remember that this account, I don't know the private keys of this account, but I can control it via XCM, which is a pretty cool thing. And so I could just go ahead and do, for example, here, a balance transfer. I'm going to select the balance module. I'm going to select the transfer. I'm going to put here that I want to transfer it to the demo account and then put some value in here. And you can see that the bytes are changing every time I put something different because this represents this here that you can see, but basically in code, in bytes, okay? So that is what I had here before, that I had here pre-prepared. It's just these bytes that represent the balance transfer, as you can see. All right. So there's not much in here. This is not the interesting part. This is actually the boring part. The only thing that you have to remember is that I have this account with 2 KMA tokens, and by the end of this demo, it should have 3. Hopefully, if everything works out. We're doing a live demo, and so live demos might not work, but usually they work. Hopefully. So the second part is that we have to go through Moonbeam, right? So in Moonbeam, I have an account called XCM Test ETH. And so this account, I have to use the right account, because remember that the multi-location derivative account depends on this one right here. So if I were to use my other account, Alberto, this example would not work, because the multi-location derivative account will be different. And if it's different, I don't know if it has funds. And if it doesn't have funds, then it will just fail. All right. And so what I'm going to do is I'm going to cheat a little bit, because I feel that for the sake of time, we should probably move a little bit faster. And so I'm going to just grab this bytes that represent the call that I want to do. I'm going to put them here so I can explain it to you in a sort of more simple way. All right. So this is the same that I would have just done this manually, step by step. So the XCM transactor palette is like a module. It's like a helper to help you build an XCM, a set of XCM instructions that are going to do a transact on a remote chain. And we're using the transact through sign method, because this is the one that actually does everything through the multi-location derivative account. The first thing that we're providing is a destination. This is a destination chain, and this is done through a multi-location. So if you think about, our feeds are a Moonbeam, and we want to target Manta. And I know, because Alberto just said so, that Manta has a parachain ID of 2084. And so basically what I have to do is do parents 1, because we have to go 1 hop up in the diagram that I showed you. I have to go 1 hop up. And then for the interior, I only need 1 field, which is using the parachain field of 2084. All right. If you want to, if you're curious about the how do you know that the parachain ID was 2084? You actually can do this, in this case, in Calamari. You actually go to parachain info, and there's a method called parachain ID, and you can actually query this, right? I went to developer chain state, and you can actually find it here. All right, so our destination was already set, and you can see that I set it as a multi-location. The next part is the fee payment, and this is interesting because we need to have, first of all, right, our dispatcher account on Manta needs to have tokens to pay for the execution. And in this case, the only thing that we're doing here is that we're telling Manta or Calamari which tokens do you have to take out of the multi-location derivative account to pay for this execution, right? So this, in Moonbeam terms, this right here in Moonbeam terms means the Calamari token on Calamari, right? There's like a mapping basically between these two. So basically, this is basically saying, hey, you can actually do this as well as a multi-location, where you specify the token as a multi-location. I don't really remember how the Manta team basically sees their own token as a multi-location, but from a Moonbeam perspective, the easiest way to do this is as a currency ID. And so the currency ID is basically the asset ID. In this case, it's not the reserve token of Moonbeam. It's not Glimmer. It's not Mover. It's not Dev tokens. It's actually a foreign reserve. And in this case, the asset ID, you can find it in this section, network assets. And then in here, you will see a bunch of assets, but you have to find the Calamari token. And so you can see that it's 213, 357, 169, blah, blah, blah. And this is exactly what I have here, 213, 357, 169, all right? So this is when the palette builds the XCM message. It's going to say, remember when we had the withdraw asset? What we're saying is that I want to withdraw KMA tokens to pay for the execution. If this would be permitted, I could actually, let me copy this. I could actually pass this, but, Calamari would have to be configured to accept Glimmer, Mover, or in this case, Dev tokens to pay for execution. All right. Cool. we're getting to it. So this is, I think the hardest part is already behind us. This is the call, and this is pretty straightforward. These are the bytes that we want to execute on Manta. And so this, if you take a wild guess, this is basically the balance transfer that we created before, right? These are these bytes that represent the balance transfer, but in this case, we're just spacing them here. Remember that these bytes have no meaning on Moonbeam, right? But they do have a meaning on Calamari. And then we have two elements regarding the weight. So the weight, if you're an Ethereum developer, the easiest but incorrect way to think about weight is that it's related to gas limit, right? It's not that, so don't take my word on it, but it's sort of the easiest way to start understanding weight. But weight is basically time of execution that this is going to take, okay? And so basically what I'm saying here is that for the Transact, for these bytes, I am giving 2 billion weight units to be executed, all right? So 2 billion weight units, one weight unit, it's 1 picosecond. So 2 billion weight units, it's like 2 microseconds or something. I'm not really good at these quick maths, but we're saying, hey, Manta, the maximum amount of time that I want you to take to execute this, it's 2 billion weight units, all right? And this is American billions. If it's more, just please don't do it, right? If it's less, then everything is fine. And this is related to the amount of tokens that we're going to actually take out. So that's why you need to provide it's sort of like, that's why I mean that it's sort of like gas limit, because this is like the maximum amount of money we're willing to put to execute. And this right here, it's similar to this one, but this is for the overall XCM message, right? So this number, it's only for this action here, but this number is also considering that you need to provide some weight for the execution of all the instructions that I've mentioned before, right? So this number has to be larger than this one because this includes the XCM message plus the weight for the Transact. So hopefully this is more or less clear. What I'm saying here is that for the 4 XCM instructions, I'm providing 1 billion weight units, which is more than enough, actually. All right, I did a lot of talking. So once I build my XCM message, and notice that I'm not building the instructions, I'm just putting some inputs, and this is going to be done for me. You can actually copy this just so you can have it as a reminder if you want to repeat this in the future. But we can actually now go ahead and submit our transaction. I'm going to put my password. And if the gods of live demos are nice to me, so this is going to be, we're going to check that an event was emitted on Moonbeam, on the Moonbeam side. There was a block, still not produced. There you go. Oh, wait, no, there was no XCM message. What happened? Did it work? I didn't see it. Oh, yeah, I didn't see the event on Moonbeam, so I don't know. There might be an issue with the events. Let me go into this block just to see, but not this one. I have no clue where the message went, but I think it, oh, no, it did not work. This message is actually an old message. Let me see what happened here. I have it correct. Let me send it again. Usually the error shows up here, so I just want to know what happened on the Moonbeam side. Oh, there you go. This one worked. I have no clue what happened before, but there you go. You can see here that there was a message, an XCM message send right here, right? This was sent by me, and this is saying, hey, you've sent a message with this instructions to this destination and with these bytes. And hopefully if we go to Calamari, we have a message being executed, which I don't really see. Let's wait and see. Ah, interesting. And there might be an issue here with Explorer. Let me see if I see it manually. Oh, there you go. Yeah, there's an issue with Polkadot.js apps at this time. So you can see here that, a couple blocks ago, Manta received an XCM message. And you can see that this message, there's this hash 780C. And in here we have the 780C message. And you can see that the message basically says that there was a balance transfer between this account, which is the multi-location derivative account that I had, to the demo account, which is a talisman account for 1 KMN token, right? And this event right here is basically that I basically put too much money to pay for the execution. And because I didn't include sort of like a special XCM instruction, there are some minor KMA tokens basically are locked, are lost, let's say. But this is a testnet, so that's not really nothing to worry about. Cool. So to show you the proof that everything worked, I have here now 4 KMA tokens, right? So, I mean, I increased my balance, I think, by 2. So actually, both of the demos might have actually worked. So, yeah. All right. Before I give it to Georgi, I want to show you one last thing. I'm not going to bring this on like, well, actually, I can bring it onto the screen. That's fine. Let me find the... want to find the block where I had the XCM message. So give me 1 second. What I'm going to do is that for this particular XCM message, I'm going to actually grab the instructions, and I can't remember which block was. Okay, it was this one. So I'm actually going to decode the XCM message so you can see the instructions, right? So let me do this, and I'll do a really, really big zoom so you see basically what I'm doing here. I'm using the XCM Tools repo that I showed you before to actually decode the XCM message so you can see what's going on with all these instructions and so on. Let me move this so I can give you more space. There we go. All right, cool. So you can see that the hash matches the message. It was a 780C. This message that was received by Manta had these 4 instructions: the send origin, withdraw asset by execution, and transact. And basically, you can see here that the send origin, it's using this account, which is the Moonbase Alpha account that I used. The withdraw asset is basically saying, hey, you're going to withdraw assets located at this multi-location, which is basically the KMA assets. And you're going to withdraw this amount, basically, the 3 million KMA tokens, but the decimal ones. Then you're going to buy some execution, and you're going to buy basically 3 billion weight units, or this amount that you're withdrawing, right? So either one of these two, whatever it buys you the least execution is going to be the one that it's going to limit you out. And last but not least, we have the transact instruction, which basically says, hey, can you execute these bunch of bytes and using this much weight, basically, all right? So this is to show you that, this is the XCM message that was crafted on the Moonbeam side. You didn't have to do this manually because the palette does this for you, right? And it does it in a way that it's a little bit more secure because you don't have to worry about all this, things and little details all over the place. So yeah, I talked for, I think, 1 hour already. So that was a long time. Before I showed you the last slide, because I'm gonna be coming back to the last part of the demo, I'll give it to Georgi, which is gonna present the part of Manta. So thanks a lot for all this, and I'll be right back. So Georgi, if you want to take the stage.
All right. Thanks, man.
Yeah. Let me stop sharing. And yeah, I'll see you in a bit.
Okay. Let's see. Let me. I want to share a screen, right? Yeah. Okay, guys. Hello. I have a short slide, like 2-3 slides, just hopefully to get you acquainted in general what our project does as it relates to privacy as well. Well, it's privacy focused, and then give you like a small demo on basic, like the general idea of how to use our software to integrate it, also just to use it, but also to integrate it into your applications. And to utilize also XCM to send over data and to do private transactions. So yeah, as Alberto mentioned, I'm George, and I'm actually an engineer doing mainly like backend stuff, the blockchain systems for Manta, and I've been with the project, I think, for a year and a half already, a little bit more. Yeah, and our main mission, I guess, is as it relates to the Polkadot ecosystem, is to bring on-chain privacy. We've already deployed our Canary network, which is on Kusama, called Calamari network, and soon, hopefully, we'll be also deploying our Polkadot-based chain, and this will obviously this allows us to privatize both those assets, the DOT and KSM assets, once they're bridged over via XCM. Furthermore, we are also able to privatize all other parachain native tokens like Moonbeam, Akala, Fala, or all of the all the other chains that exist. Basically, our private ledger supports multiple assets. And it's kind of like, well, it uses zero knowledge proofs to privatize like the data that relates to the information of the user and the information of the asset and the amount of the assets. And I guess it's kind of like Zcash, but again, it supports multiple assets, not just the Calamari or Manta native token. Yeah, and also we can support not just the native tokens of other parachains, but any kind of like, I guess I'm not sure if derivative assets is a good way to describe them, but the XC20 tokens, which are created on Moonbeam, yeah, we can support even privatizing those. Soon we'll be actually making the assets that we can support permissionless, so anyone will be able to create an asset and privatize it. Not just an existing one, and yeah, soon after that we'll also have a support for non-fungible tokens, which can have different applications than the general fungible tokens transfers that we privatize. Right. So this slide is kind of aims to show just general architecture of the whole system, of how privatizing other parachain assets would work. As you guys can see, there's this. So let's say this is Moonbeam. We have the Calamari asset here. Through the XCMP transportation system between parachains, we can bridge over the asset to the Manta public ledger, which is the general substrate functionality. And at that point, we can also create a private version of this public asset, which will exist in the private ledger of our system called Manta Pay. This is just a pilot that we've implemented that runs in our runtime, and that's where the zero knowledge proofs are verified, and the transactions can be obfuscated. Like I said, the identities, assets, the asset type, and the asset value, and you can transfer them around. It's a UTXO ledger, so it's kind of like Bitcoin in that sense, but there's no link between the inputs and the outputs, and the values in the asset. Right. So let me see what else I have. So I guess this is my last slide in terms of just the general architecture. Yeah. What else? Yeah. There's this slide. You guys can, if you guys want to learn, have a deeper dive into all of our everything that we are about. There's like a Discord, which is pretty active, a Telegram group, obviously the website, and you guys can tweet at us. Right. So the other thing I wanted to do is to show you how you can basically. So let's say your app exists on. Let's say your app exists on the Manta. You want to work directly with Manta and Alberto will show you guys how you can even integrate it on another chain and send messages to XCM. So to basically work with our system, which is the main thing is creating these zero knowledge proofs that can be verified on chain, right? That include all the transaction details. For this, there's one piece of software which is really our wallet, our private wallet. It's called Manta Signer. It manages, it creates the ZKPs, it does the cryptography work, and also manages the private keys that are related to all of your ZK addresses. That's what we call the private addresses in our ledger. So just like any other signature scheme, you need to have these keys that spend, right? And that's managed by the signer. So for now, we're assuming that this piece of software is kind of running in the background for the user. The user has already installed it and already created it, and I'll show you exactly how that works. So you guys can, for the builders out there, you guys can set it up and you can test it. The other second part is our SDK, which will work with the signer and also kind of generate the required data for the ZK that you can then use to submit transactions. So it's kind of like how it's just some code that can allow you to use the signer to get the correct and to build some front end on top of it. Okay, so right now let's just jump to the demo. Actually, let me see if there's any questions. Not sure. Guess not. For the demo, I've already. I will send you guys, I guess, the link to our. This is all open source, so the signer and the SDK. Just bear in mind that we managed to get this functionality ready for the demo, but we still need to clean up the documentation a little bit. So tentatively, hopefully very soon, we'll have a nice document for the hackathon for sure. There will be nice documentation how to use this, because I've had to do a little bit of setup before we started. So, but right now, what I'm gonna do is just run the signer for the first time on a machine. I'm building it and running it. It's gonna take just a few seconds. Oh yeah, and before that, actually, yeah, just like Alberto was showing, I have a Calamari parachain open, which is this is running on the Moonbase relay chain, and it's connected to the Moonbase Alpha parachain of Moonbeam guys. This is what we've been using to test this. So right now, the signer is starting up. It has so this is part of it is a ZKP generation tool. The other part is a wallet. So just like any wallet you want to create, I'm going to give it a password. And yeah, this is a nice functionality that all wallets should have. So it's making me save this. Okay, you guys should always save your place. I'm just gonna paste it here, so because it's gonna ask me to rewrite it. Where is it? That's that. I'm moving from to them. Let's confirm this. Now I'm gonna log in with the account I just created, and this is currently says I need to append this to also say that supports this testnet, but we'll see. Anyway, it's gonna be right now. It's not really gonna connect to anything. That's gonna be the next step. But okay, so now it's running in the background. I have this wallet, and it has a wait. There should be some more front end for this app. Basically, it needs to show me the the ZK address for my wallet, but let's just assume I have it. And now I want to run the SDK. So in the SDK repository, there's an examples page, and one of the examples is basically this piece of code, which we need. From this piece of code, we need basically the sign result, which is this is the encoded call data for our transaction. We actually, our ledger, maybe open. So this our ledger actually has 3 functions. One function to mint from a public asset, mint a private asset, and then a function to transfer, to do the private transfers, and then a function to reclaim, to make a private asset public, and then so this piece of SDK code that we're looking at is to just do a mint for the example. Basically, create a. So here it's going to take. It's going to take one. It's going to take Calamari asset, which is our native asset, and it's going to take one with 12 zeros, so just one KMA, basically, and make it private, and create a private version of this asset. Right. Anyway, and it's gonna send it to the private address, which is gonna get from the signer that we just run. So there's a bit of setup that I've done here, but the last part is to run this example. And what this is, let it run. And this is basically gonna print some data that we want to take. And it's going to print it in the console. So, but obviously, this is in the final version of this SDK. You won't need to do this manually. It will be much more straightforward to use. So let's just open the console. As I said, there's going to be some data here. Yeah, it also actually, so the SDK actually connected to my Polkadot.js, and it understood what my accounts are. Because the public account that I want to use is actually this Alice. It's a well-known account, but I funded it. So my well-known account is Alice, and Alice is gonna privatize some of her Calamari token. And right now, so this is my private address, which should have shown up as there's something with the signer that probably needs to be fixed. There's like a front end where you can choose different private addresses, and yeah. Anyway, this is it. And now the data that I want is actually printed a little bit below. This is the data that I want. It's basically my whole transaction, and I can show it to you by going to the extrinsics tab, pasting it, and so basically decoding it. Yeah, you can see how it's Manta pay. The 2 private is the minting function, or out of the 3, or the private transfer. Well, there's also public transfer, which is just a kind of like a helper. So the main ones are private transfer, 2 private, and 2 public. Yeah, and this is all the data that's required to do for the ZKP, and there's data related to some of the private addresses, how to spend it, and yeah, the proof is at the end. And we can submit it. Anyone can submit this. It doesn't have to be the the person who submits it needs to have the money, so the 1 KMA, but as you can see, Alice has like 20 billion KMA, so it will pass, and it did pass. And the event is actually fairly straightforward. So yeah, this is basically showing the mint was successful, and we now know that some the 1 KMA was privatized. Obviously, at this point, we know that this 1 KMA is owned by Alice, but Alice can easily break the link with 1 private transfer, sending it some other private address, and then at that point, no one will know. Yeah. Or Alice can also ask someone else to sign this transaction. This payload that I copied, that was returned by the SDK. She can have anyone submit it actually, and yeah, the private address of Alice will still be able to control it. So the private version of the asset will be controlled by some private key that's owned by Alice, but someone else can submit the public part of this transaction. Anyway, just in general, you need this encoded data of either the to private or the private transfer, the to public, which you get from the SDK, and you can use that in your applications to submit transactions on a chain. Those are really just private transfers, or minting or reclaiming the asset. And then, right, I think that's pretty much from me. I think the next part is, which Alberto will show you, is how to use this data that we got from the SDK, but use it in an XCM to send it from the Moonbeam parachain to our chain and still do the private, still have this succeed.
Yeah, correct.
One question in the Q&A, if you could answer it.
Let me see it. The final version of Manta Signer. Well, this is the pretty much, in terms of the cryptography, this is the final version for. Hopefully, it is gonna be the final version. It's being really stress tested. It's being stress tested as we speak. For our release of official release on Manta Pay on Calamari, which is the Calamari network we have, right? So yeah, that should be the final version. Obviously, there's gonna be some front-end changes that need to be done. Maybe there's gonna be some front-end bugs. I don't know. We'll see. But the cryptography side that's the final version. Yeah, and right now it's being tested. I think we're aiming for some January or at some point in January to actually have it released. But right now, you guys can use this software. If you're really curious, before we actually make an official release, you can just go on the development branches. I guess I'll link which are the development branches that I just used, and we'll be appending documentation to those. And you guys can subscribe to these two repositories, to Manta Signer SDK, and see as we build out the documentation. And, any feedback will be really appreciated.
Cool. Thanks, George.
Oh, there was another. Smartphone. I guess. I'm not sure. No, I'm not. I don't think I'm not sure actually if this is being planned, but there is a plan. I think there was a plan to get it into because this is like a desktop application right now. There is a plan to have it become a browser extension, which can be done with WASM, but this is under development. Right, and the other thing I personally kind of want to make, I want to make the SDK kind of embed this signer, so you don't have to assume that users already have this signer, but you can just once you embed once you use the SDK in your app, and then the first interaction with it maybe somehow downloads the signer and navigates them to the process of actually using it. So I kind of want to make this a little bit simpler, not have this assumption that it's already running, but also, and then it's gonna soon it will be as a extension in the browser, using WebAssembly. So this will disallow private dot or KSM transactions, right? They will have so you have the dot, right? Polkadot or Kusama. You send that Kusama or dot to Manta or Calamari, At that point, it's still public. Then you can create the private version of this token. Then you can do the transactions with the private version. So it's not like it's going to be private transactions on Kusama, but there will be private transactions on Calamari using like a wrapped private version of Kusama token. So yeah, you will be able to. I mean, we'll bridge over. I think we've already bridged over Aurora, Kala, Moonbeam, obviously, the Moon River asset, and we'll bridge over all of them, hopefully. And we'll make it permissionless, so anyone will be able to create, kind of like on Stateline. Anyone can create an asset there, right? So we want to make it like this as well. And then also be able to mint NFTs. So.
Cool. I think I can take over for that final part of the presentation. Thanks, Georgi. I think it was pretty cool. And I do want to say that, a lot of the stuff was like, just released really, really shortly. And so, there's not a lot of documentation and stuff. So hopefully, this will be sort of provided so that you guys can use it. But it's really cool to see how, you can do private transfers and so on. And so now the next example that I'll do, and I'm going to take over the screen now, is to sort of like combine what George just presented, but now sort of from an XCM perspective, right? So just to do a little bit of summary, basically, he was able to create this like bytes. Remember when we were doing the XCM Transact? He was able to create the bytes that we were going to provide to the XCM message so that we can do the private minting of the asset, but initiated from Moonbase Alpha, from our testnet, okay? And so one really important thing is that this private minting will happen to the wallet that created the bytes, right? So it's not, in this case, it was not me. Georgi just gave me a bunch of like, bytes with the 0K proofs and everything, so that I could do it from Moonbase Alpha. But in the world that if I want to privatize my assets, I would have to generate this myself and then use this on Moonbase Alpha. Ideally, in the ideal world where everything is perfect, I do see in the future sort of like a way to have like a slider that is like, privatize with Manta or privatize powered by Manta. And then underneath, there will be a bunch of XCM interactions that will allow you to sort of like privatize your asset transfers. And one thing we none of us discussed, like not even Anna, Agnieszka, Georgi, and I, is like, what things can you do, right? I mean, I think we discussed this on the Twitter space, but the idea is that, we're going to start with a very simple, private transfer, but, you can have to think about as well what this unlocks, right? So if Alberto on Moonbase or Moonbeam, or let's say Moon River, goes to Calamari and I privatize movers there, I can do a lot of things. I can do like private payrolls. I can do...
One question, because we don't see your screen. So
no, I'm not sharing. I'm doing some. I'm sharing some thoughts, and I'll do the screen sharing. No worries.
Great.
Yeah. So I mean, once I privatize assets, the possibilities are, I would say, endless. Like you'll have to think about them, but some of them that we brainstormed were, private payroll or even like private staking, because once you move this to, Manta or Calamari and you privatize them, you can bring it back to Moon River, but like you already privatize these assets, so there's no traceability to the original account, and then you can stake on Moon River. And then also you can do private voting using the same mechanisms, right? So the idea is that, you in the hackathon will have to sort of think about these scenarios and, build them yourself with a sort of like a simpler UI and sort of provide this to end users. So I think we all forgot to say what's the purpose of all this stuff and how you could use it, right? All right, now I'm going to share my screen. I'm going to put my... So I'm going to go back to Moonbase Alpha, to Calamari and the Explorers. I'll actually be using the same basically XCM transactor and transact through signed. So all of this is going to be very, very similar. There's only going to be 3 changes, and I'll go through them, right? So I have here in my notes, right? In my notes, I have here 3 private mints bytes, basically, that Georgi constructed and gave to me, via a DM, a direct message. So what I'm going to do is that I'm going to, grab one of them, go to Calamari, to ensure that this works, right? If I decode these bytes, here in intrinsic code, you can see that this is actually something that Manta understands. In this case, Calamari understands, right? So this is a private minting that is happening here. I'm going to do one that is actually, I think this is not going to work because I used this one already, excuse me, and when I was testing this out. But just for the sake of this example, I'm going to use it and see what's going to happen, all right? So what I have to do, and I'm going to build this from scratch so you can, see it and go through it with me. So I am going to click the XCM transactor palette, which is the palette that allows you to build XCM messages basically with the transact instruction in a simpler way. And I'm going to look for the transact through signed function, right? For the destination, we're going to use multi-locations v1, and then we need to go from Moonbeam to Calamari, and in this case, we have to hop one level up. We need to provide a field, which is parachain, and then 2084 as a parachain ID. Excuse me. So for the fee payment, I think what I'm going to do now is that I'm going to use, in this case, let's use multi-location. I've not tested this before, so we'll see if I remember correctly. But basically, this multi-location right here, even though it seems similar as a destination multi-location, this is how Manta or Calamari sees its own token, right? So if Calamari says, hey, as a token, I want to use this multi-location, they'll understand, oh, okay, so this is a KMA token, all right? For the bytes, I need to provide the bytes that, I already showed you here. This is the call that we want to execute on Manta. And so in this case, or this one. And then we need to provide the weight, or remember the amount of execution time that we want to buy on Calamari for this call. And then also the overall weight, which is, all right, so I mean, how much weight do you want to provide for the XCM execution message itself? So because this call is quite expensive, I'm not really sure how much it would take. So I'm going to put a very large number. And the maximum is actually 20 billion. So I'm going to put 17 billion, right? And for the overall weight, I just want to dedicate 1 billion because we know that this worked before. 1 billion for the XCM message execution. So the overall weight will be this plus 1 billion, which is 18 billion. All right. So hopefully, if I did everything correctly, because I built it out from memory, I'm going to sign this transaction. And then what should happen, I think this one is going to fail, but it should not fail on Moonbase. It should fail on Calamari because I think these private minting bytes were already used before. I'm not 100% sure if I picked the wrong one, but I'm trying to pick the wrong one. So just to show you. Just to show you that this process is also async, right? If it's successful on Moonbeam, doesn't mean that it's going to be successful when it gets executed on Manta. So you can see here that I have my XCM message was sent, as you can see here. I'm going to go to Calamari, and then XCM success. Oh, actually, yeah, this worked. So, I mean, this is probably the wrong one. I actually used a good one, all right? But anyways, this is just to show you that basically I was able to, in this case, I privatized KMA assets, all right? And these assets were held by like the assets themselves were held originally by the Moonbeam multi-location derivative account that for whatever reason is not showing up here. But the private UTXO now, it's owned by the account that Georgi used to create this bytes, okay? So I privatized, I did a private transfer where the origin is known, but the sender, the recipient of this assets is not really known, all right? And so, yeah, I mean, now I could, if I did it, I could have also done the transfer scenario using, the private, basically I did a pseudo private transfer, let's say. And so, yeah, I guess this is to show you that basically this XCM message was successful. And we can also now decode this very, very simply by just providing the newest block, which, if I remember correctly, is 11703. So I'm going to decode the 11703 message. And just to show you what this script is doing, there's some weird issues with... There's some weird issues with Polkadot JS apps at this time. Let's see. All right. So you can see that what happens is that this part is where actually the XCM message is received, and you can see that it received a horizontal message from the parachain ID 1000, which is Moonbeam, and this is basically the block, the bytes that were sent with the XCM message. All right. So if we look at it, basically it's the same one as before. Excuse me. It is a descent origin, withdraw asset, by execution and transact. In this case, the withdraw asset is to pay for the execution. The descent origin is to calculate the multi-location derivative account. We're buying some block execution time. And last but not least, we're doing a transact in which we're providing now the bytes that I was given to by Georgi, which is going to do the private minting of these assets. We tested already. I think we tested at one point, I'm not sure, to privatize dev tokens. So dev tokens is the native token of the testnet Moonbase Alpha. And actually you can also privatize, dev tokens. And we created an ERC20 on Moonbase Alpha called Privacy on Moonbeam that you can actually, get as well sent to from Moonbase to Calamari, and also privatize using the SDK and the signer to get to create the sort of the proof, and then put the bytes on the XCM message to privatize these assets. All right. So I think that's all I had for you and Georgi as well. So there should be a lot more to come in terms of documentation, making sure that these things are clear. But XCM is quite new, and we tested this out probably 2 or 3 weeks ago, and so this is all also quite new for us and quite exciting. And so now, just to show you the last bit of my presentation, you have here the QR code in case you want to see the slides. I'm going to actually share this in the chat. Let me find it. Oops, this is not it. It's this one. So this is the URL to the slides, and I don't see any new questions. So if you want to learn more about Moonbeam, you can go to moonbeam.network. You can find our documentation at docs.moonbeam.network. You have the Telegram, the Discord, our official Twitter, and you can find me in Telegram as Alberto V19. I'm one of the admins in the Moonbeam official channel. So make sure that you DM me, because there's impersonators as well. And if you have any questions, comments about this activity, let us know. We're happy to help. And yeah, I think this is really cool because it's showing a little bit of a more useful use case for XCM that it's just not typical token transfers. So yeah, thanks a lot for tuning in. I'm gonna stop sharing.
Thank you so much. I see that there is one question in the chat. Does Manta have documentation to help understand how to use ZKP? I think that's a question for Georgi.
Right. Yeah. I mean, I think we're building this out right now. It's the SDK is the way you guys, builder, would use to create the zero knowledge proof, submit the transactions to our chain, right? So we're focusing on building that documentation out now. I mean, I think I'll start. Well, there was one other engineer who was developing the whole SDK, and now both of us will probably write some documentation over the next 1 or 2 weeks. Yeah, and there's already example code. Let me actually send. I guess let me send the where's the chat? I just send the SDK README. It's already a little bit, so you guys can like wet your beak, I guess. But I probably this won't be enough to get you started. You also need the signer. 1 second. But yeah, this is one of our priorities over the next. Now that everything is working and we're at the phase of just final stress testing the whole system before we're releasing it, we can finally start writing documentation. And the signer is here. Soon. But in the README there's some examples. Check out already.
Okay. I don't see any more questions. So thank you, Alberto. Thank you, Georgi, very much for everything that you presented today. Okay, so we are slowly wrapping up. Let me just share my screen now. Okay, I hope you can see everything. So we wrapped up our second event of privacy on Moonbeam. Like I told you, the first one was the Twitter Spaces that we did. So what to look out for? I know that Hector is keeping with our presentation. He will provide you the link to the Polkadot newsletter, because we are planning our Privacy on Moonbeam in-person event. It's going to be a workshop around April 2023. So look out for that. I see that the link is already there. So sign up for the newsletter. Like this, you're up to date and you're not going to miss it. Once again, I would like to thank Moonbeam Treasury for supporting this event series and our media partners, so ZK Podcast. Like I mentioned at the beginning, this session was recorded and it's going to be uploaded on the YouTube channel of the ZK Podcast. Keep in touch with us. If you want to know more about ZKValidator, if you want to see more events, more initiatives that we are doing, look at our website or our Twitter. And if you have any questions, obviously we're here to answer them. Write to us at events@zkvalidator.com. And again, remember to subscribe to Polkadot newsletter if you want to know about the events or news from the ecosystem as general. And that's it. That's it from us. I hope you all enjoyed the event. Thank you very much for the participating again. Thank you very much to Manta. Thank you very much to Moonbeam, to the teams for bringing it all together. Thanks again, and see you on the workshop in person. Bye-bye.